So we're writing a method fib that takes in an integer n and returns the nth Fibonacci. Fibonacci sequence is a numerical series where each item is the sum of the two previous items. So like 0 plus 1 is equal to 1, 1 plus 1 is equal to 2, 2 plus 1 is equal to 3, 2 plus 3 is equal to 5, and so on. So I'm writing this in Ruby. There are many ways that you could write a solution for this. So let's start it off with, you can go with an array and loop through the array and continue to fill out the array, and then at the end just fill out, if you reach the nth, return that nth because that's the index of it. So start it off by calling it sequence, and so you start off by filling it with a 0 and a 1 because we're starting at 0 and 1 and we're indexed 0 and 1, and n is going to be the index basically that we want to return. And to begin with, we want to raise an argument error for this specific interviewCake question if n happens to be a negative number, because there's no such thing as a negative index in a Fibonacci sequence. It starts from 0 and keeps going towards positive. So we can do a n dot times do, because we want to loop through every time, and then we want to grab the sequence. We want to keep on populating the spots in it. Actually, I'm going to do a for I in 2.n do, because we're starting at index 2. We could set sequence at position of I, which is going to be right here, to be equal to sequence the last two values. Sequence at I minus 1 plus sequence at I minus 2. And then we'll just return at the end sequence at the position of n. And that one works for this way. So this one is a uses extra array space. So that would be big O of n space time n space, because we're going from 0 all the way to n. We're doing those calculations and we're using extra space. So another way we could do it is the recursive approach. Recursive. And this way we would basically, we would be calling fib n over and over again. So our base case to kind of make it return or stop would be if n is equal to 0 or n is equal to 1, we would just want to return n, because let's say if we were at 0 or 1, if we're trying to calculate the fib of index 0 or 1, then we would just return 0 or 1. But once we get to 2, that's 1, 3, that's 2, 4, that's 3, right, and so on and so forth. So we could just do that, and then else we can return fib n minus 1 plus fib of n minus 2, because what that would do is, let's say if it were 2, if n were 2, we would pass this and we go into here. 2 minus 1 is 1, which would call again, and that would just return 1. Fib n minus 2 would be 0, and then return 0, and then would return 1. So that means the position of n, we're returning the number 1, which is correct. So this is just a straight out recursive approach, but that would take a big O of 2 to the power of n, which is and then like big O of 1 space, big O of 2 to the power of n is terrible. So what we want to do is recursive with memoization. So that if we did a calculation, let's say fib of n, I'm sorry, fib of 2 or fib of 6 or fib of 7, if we already reached there, if we already did that, just save that value in a hash so that we don't have to do all those like stacked call calculations again, because we already know the resulting value of that. So we can start off with a memo as a hash or an object to store that, any calculations, as a key value pair. And so this one similarly we could do if n is equal to 0 or n is equal to 1, we would return n, and then else if we would do if our calculation happened to have been in our memo, we would do memo at position of n. Well, actually we do, since ruby.include position of n, then we would return memo at the position of n. Else, we would just do we would save it in a variable called result, because now we want to actually do that recursive call. So the same thing would be fib of n minus 1 plus fib of n minus 2. That would be our resulting result. So memo at position of n, we would store that result in there now, and then result, and then we would just return results. And then that should be that for the recursive with memoization. And then we could further optimize this by not using memoization, recursion, any extra array space. We could just use pure iteration and temp variables. So what we could do here is we'll just use a few variables that are just going to juggle values, and then we're just going to return like the final value at the end. So basically we could have like let me think of first or second. I'm gonna call it 1 is going to be 0, 2 is going to be 1, because we're starting right here, 0 and then 1. So basically we could do n dot times do end. So let's say n was 7, we do 7 times do. Ruby, just like I think in JavaScript and Python, you can do the swap variables just like this. So 1 comma 2 is equal to 2 comma 1 plus 2. And then I believe that swaps 1 for 2 and then 2 for 1 plus 2. And then when we get to the end, we could just return 2. I might be off by 1 in the iterations, so it might be n minus 1 times do. Oh, and then there's the 0th Fibonacci case. If same thing with the recursive version. If n is equal to 0 or n is equal to 1, and return n. So then that one works for that iteration, and then there's just another iteration type that you do just with different variables, but basically return n if n is less than or equal to 1, and then we'll have the same thing, 1 is equal to 0, 2 is equal to 1, and then we could do n dot times do end. And then this one, we would use a temp variable, like a third temp variable is equal to 1. Just hold on to 1 because now we want to swap 1. 1 is going to be equal to 1 plus 2. And now 2 is going to be equal to the temp. And then we just return 1. And that should be it for that one. And this one is big O of n time, and should be big O of 1 space. Duration big O of n time, big O of 1 space. Okay.